Hey everyone, and welcome back to another Dr. Cool Cat Explainer. I am so glad you're here. If that GED science test has been looming over your head, making you a little stressed, well, you're in the perfect place. Today, we're going to pull back the curtain and demystify the whole thing, because there's one major secret to acing this section, and we're going to break it all down.
So let's just dive right in, because this quote right here, this is the key to everything. I mean it. If you've been spending hours trying to cram your brain full of scientific facts, formulas, and definitions, you can just take a deep breath. Seriously, the test isn't designed to see if you're a walking, talking encyclopedia. It's designed to test something way more useful.
Here's really the best way to look at it. The GED science test, it's not a trivia show where you have to buzz in with random facts. No, it's a detective story, and you're the detective. The test gives you all the clues, in the passages, the charts, the graphs. Your job is just to use your logic to analyze those clues and solve the case. It's all about how you think, not what you know.
Okay, so that brings us to our first and most fundamental skill, thinking like a scientist. Now, don't let that phrase scare you. This is not about memorizing complicated lab procedures. It's just about understanding the simple, logical way that scientists and you can answer questions about the world.
And to make this feel way less like some stuffy science class, we're going to use an example that I think we can all relate to. The classic case of the droopy houseplant. Come on, we've all been there, right? You walk by and you see your favorite plant just looking sad and wilted, and that process you go through to figure out what's wrong, that is literally the scientific method in action. I mean, look at this. It breaks down our thought process perfectly. You start with a simple observation that leads to a question. Hey, why is my plant wilting? Then you form an educated guess, a hypothesis, like, maybe it just needs some water. That leads to a really clear prediction. Okay, if I water it, then it should perk up. The experiment is super simple. You water it, and then you get your conclusion. If it perks up, awesome. And if not, that's not a failure. That's just data. It just means it's time to test a new hypothesis, like maybe it needs more sunlight. Okay, now to really understand the experiments you'll see on the GED, you have to know about the two types of variables. First up is the independent variable. This is the one thing that you change on purpose. And here's a little memory trick. I change the I independent variable. Got it? Then there's the dependent variable. That's what you measure to see the result. Its outcome, depends on what you changed. All right, let's look at a real GED-style example to see this in action. Let's say some scientists want to know if an enzyme called pectinase can help get more juice from apples. So look at the table. What's the one thing they are changing on purpose between beaker A and beaker B? Well, they're adding pectinase to one and just plain water to the other. That makes the pectinase our independent variable. So what are they measuring to see the effect? The amount of juice produced. That's our dependent variable. Everything else, the amount of apple, the time, it all stays the same, because that's what makes it a fair test. All right, let's switch gears to our second superpower, decoding the data. This is a huge game changer, because nearly half the questions on the science tests are going to involve a graph or a chart or a table. But here's the best part. The answer is always, and I mean always, right there on the screen. You just need to know how to find it.
So here it is. This is your secret weapon for every single graph you see. Before you even look at the multiple choice answers, you do these 4 things. First, read the title. It tells you what the whole thing's about. Second, look at the axes, the x-axis on the bottom and the y-axis on the side. What are they measuring? Third, find the key or the legend. And finally, fourth, just ask yourself, what's the overall trend here? Is the data going up? Is it going down? Is it staying flat? I promise, if you follow these steps, you cannot go wrong.
Let's put our strategy to the test right now with a typical GED problem. So we've got this graph. Step 1, the title. It says solubility of salt and water at different temperatures. Okay, we know what we're looking at. Step 2, the axes. The x-axis on the bottom is temperature, and the y-axis up the side is how much salt dissolved. Step 3, no special key or legend needed here, it's just one line. So that brings us to step 4. What's the trend? As you look at the graph from left to right, what is that line doing? Okay, let's break it down together. As we move from left to right along the bottom x-axis, the temperature is increasing, right? And as that temperature increases, what happens to the line? It goes up. And what does the y-axis measure? The amount of salt dissolved. So a higher line means more salt. It's a really clear relationship. As temperature goes up, the amount of salt you can dissolve also goes up. So looking at our options, The only one that can possibly be true is C. As temperature increases, solubility increases. See? The answer was just waiting there for us to find it.
Now, of course, not all the data you see on the GED is going to come in a nice, neat graph. Sometimes it's presented as a scale, like the pH scale. And on the surface, this just looks like a simple little number line that measures how acidic or basic something is. But there is a very common trap here that catches a lot of people.
And here is the absolute key thing you have to remember. The pH scale isn't linear. We're going from 1 to 2 is the same as going from 2 to 3. Nope, it's logarithmic. In plain English, that means that every single whole number step you take down the scale isn't just a change of 1, it's a jump of 10 times the acidity. So something with a pH of 5 is 10 times more acidic than something with a pH of 6.
So, let's think about this. If a question asks how much more acidic orange juice at a pH of 3 is compared to coffee at a pH of 5, what's the answer? Well, it's 2 steps on the scale, but it is not twice as acidic. No way. It's a 10 times jump to get from 5 down to 4, and then it's another 10 times jump to get from 4 down to 3. So what's 10 times 10? That's right. The orange juice is a whopping 100 times more acidic. That's a massive difference, and understanding that 10x rule is absolutely crucial.
Wow. Okay, we have covered some seriously powerful ground here. So let's just zoom out for a quick second and lock in the core strategies that you're going to take with you to that test.
So, let's just put a bow on this. You now have 2 incredible superpowers for this test. First, you know how to think like a scientist, how to isolate those variables to really understand cause and effect. And second, you can decode any data they throw at you with that simple 4-step method. Just always remember, the GED is built to test your reasoning, not your memory.
You've honestly made some huge progress today in understanding the real logic behind the GED science test. So as we wrap up, I'm really curious, which one of these ideas was the bigger aha moment for you? Was it breaking down the experiments to find the variables, or was it getting that foolproof 4-step strategy for tackling graphs? Drop a comment below and let us know which one clicked for you.
Seriously, fantastic work today. Remember, you're not just a student trying to memorize facts anymore. You're a detective solving a case. Keep practicing these reasoning skills and you are going to be in fantastic shape. You've totally got this. And hey, if this explainer helped you out, do us a favor and hit that like button and definitely subscribe for more from all of us here on the Dr. Cool Cat team. We'll see you next time.